Medical measurement and integrative systems on IoT applications. Recently, applications based on the IoT concept have been largely connected to our daily life with the advances in communication technology, including 5G, Bluetooth, and Wi-Fi. Many healthcare systems try to embrace the IoT technology in their clinical scenarios, which leads many integrated circuit manufacturers to join and play a role in innovating the IoT applications. IoT can be used in different healthcare scenarios, such as long-term care, home care, or even telemedicine, and help the doctors or healthcare professionals solve medical problems more efficiently. The pandemic of COVID-19 further boosts the need for IoT, since IoT can minimize the needs of contacting the patients for healthcare professionals while keeping their physiological conditions under surveillance. It can guarantee the patient's safety and minimize the exposure of healthcare professionals to potential risks. To prepare our students in the IoT era, one of our department's core aims is training students to equip with the skill set in building a complete IoT device. The first part of this video will be about what facilities and sources our department provides to support the students' learning. In the second part, we'll be introducing what devices we apply and how we apply them in medical and home care scenarios. As IoT grows in importance for daily life, from smartphones to smartwatches, healthcare professionals will be challenged to take advantage of IoT, monitoring the patients regardless of their identity, the time, and the distance. Patients from remote areas and bedridden elders, for instance, are monitored and their physiological indexes are sent back to the healthcare facilities by IoT devices, without them coming to the hospital. Therefore, learning how to develop a complete IoT application from scratch is one main focus in our department. We provide facilities like engraving machines for printing miniaturized circuit boards and 3D printers to design the outer case for building the prototypes of the medical devices. During COVID-19 pandemic, our IoT system was implemented as an in-hospital telecare service to monitor the patient's vital signs in isolation wards, minimizing the risk of exposure to the suspected subjects as well as the use of the personal protection equipment. We've also built a couple of devices targeting the users at home to analyze the data recorded in home settings and categorize their conditions as healthy or subhealthy, such as chronic inflammation. Coming up next in this video, we'll walk you through how IoT devices are made using core facilities and resources of our department, and how they are used in hospital or home settings. NI-ELVIS 2 Circuit Testing. It is necessary to validate that the design circuits can function normally during the development of medical devices. Students in our lab can conveniently carry out different kinds of experiments by NI-ELVIS 2 platform. The platform integrates all the development apparatuses, including function generator, oscilloscope, and bolt plot. Let's take a look at the breadboard. The circuit for electrocardiogram has been set up, and the electrode patches have been attached to the user's left and right hand. The electrocardiogram of the user will be recorded by the circuit and input to ELVIS. After switching to the oscilloscope, the user's real-time electrocardiogram can be shown on the screen. That means the circuit is functioning normally and successfully passed the validation. This circuit design can move on to the next step, the circuit layout and engraving. Circuit engraving machine, printing out the circuit board. The purpose of building a circuit on the breadboard is to test if the structure of the circuit is correctly designed. It is still far from a ready-to-use device. Appropriately amplifying biological signals is a minimal requirement. Knowing how to protect the circuit from electromagnetic interference generated from the circuit itself or electric devices nearby is challenging. especially for a miniaturized circuit. A real sample of the design circuit needs to be printed out for further testing. We can demonstrate how to design and lay out a circuit with the constant current in software, as shown on the screen. After laying out the circuit diagram, we can move on to the next step, placing the components on circuit boards. When all the necessary components and the connections between the components on the circuits are carefully planned, we can obtain a design layout, and then it will be imported into the engraving machine for printing. Traditionally, etchants are used to make a circuit board. However, due to human error or uneven etching rate, the circuits may be misconnected or incompletely etched. The aforementioned reasons make it difficult to miniaturize the circuit board. Therefore, using an engraving machine can provide a better solution for the miniaturized circuit board. The most important feature of the machine is that it controls the mechanical grinders to precisely remove copper surface and drill holes instead of etching them out. In addition, the grinding path will be precisely engraved by importing the final layout to the software, instead of human operation during etching, providing more delicate manufacturing. 3D printer, production of the functional prototypes. After function validation of the circuit board, we will use 3D printers to construct an outer case to make an aesthetic prototype in clinical trials. The Dual 300 not only makes the sample with better accuracy, but also constructs the object by combining soft and hard materials. It is especially suitable for developing hand tools or wearable items. More specific but large variety prototypes can be built by this 3D printer. It can also reduce the production costs under the trend of smart manufacturing. 3D printing holds a highly custom-made characteristic, and the customized prototypes may also increase the willingness of patients to wear the devices. Therefore, applications of 3D printing techniques in constructing highly customized products like prostheses or assistive devices are perfect solutions. In the beginning, we will design the outer case in develop mode of Creo parametric software. A STL file will be exported after design, and it will be imported and reviewed slice by another software. In the slicing software, we can adjust several essential parameters of the materials we plan to use, including filling density, consumables, printing rate, platform temperature, and so on. After modifying the settings, we can preview the simulated processes of how it will be printed and the path during printing. Once we confirmed all the parameters and the expected working processes, we can save and export the configuration file and automated build the outer case by the 3D printer. Medical IoT, clinical applications. To introduce the healthcare applications of IoT technologies, I would like to briefly explain the basic principles of electrocardiogram. Clinically, we can determine users' heart rate through electrocardiogram or the heart's electrical conduction through ECG waveform. Even for the seemingly healthy individuals, we've also obtained some interesting information. For example, we can objectively quantify their autonomic nervous system's function by the variations of the B2B heart rate intervals. To fill the gap of unmet needs, we've developed two kinds of medical devices, home use and for hospital settings. Bluetooth and Wi-Fi integrate wireless or 4G, 5G internet for IoT data transmission, which is being controlled by microprocessors throughout the whole data acquisition process. On-site IoT devices collect users' physiological signals and upload them to cloud servers after encryption. The data of each user can be managed and translated into meaningful physiological biomarkers on the server. The user-friendly interface can take full advantage of IoT by giving instant feedback to the users without spatial and temporal limitations. Another user interface was designed only for healthcare professionals, keeping them updated on patients' health without delay, whenever and wherever. For home use scenarios, the feedbacks of physiological signals and indexes can be translated into layman's terms and transmitted to smartphones firsthand by Bluetooth. If any abnormalities are detected, users will be warned and advised to see a doctor as soon as possible. Healthcare professionals can have the clinical evidence of events for earlier diagnosis. Better healthcare quality and the quality of life for users can be achieved. This is an electrocardiogram recorder we developed for home users. Users only need to put their thumbs on the two silver electrodes for 2 minutes, and their electrocardiogram will automatically upload to the cloud server by the IoT function of the device. The data will be analyzed and the users will be informed of the results for their health conditions. To help fight the pandemic, we've cooperated with multiple hospitals, adopting Wi-Fi and Bluetooth function to original 24-hour continuous physiological signal monitors, so that electrocardiogram or blood oxygen saturation data will be instantaneously sent to smartphones and cloud servers. The healthcare professionals can avoid unnecessary visits of the patients in the isolation wards, while keeping the patients connected and their vital signs monitored, to facilitate a win-win situation by the IoT device.